Hello, everyone. My name is Zsolt Pulai, and I'm the Executive Vice President of Technology and Engineering here at AZIO. We live in a time where electronic devices around us are a critical part of our everyday lives, and some of these devices are so deeply integrated into our everyday lives that we don't even realize they are around us. We only realize we miss them when something happens to them, something goes wrong. When these devices fail, there are challenges and consequences we need to solve and face. And because we heavily rely on these devices, they need to be operational under any circumstance. Today, during this webinar, we will explore these challenges, and then we will discuss what we can do to provide protection against the environment. This webinar will explore the needs and challenges we face with these devices, and then we show you a solution how to prevent the failures associated with these products. While I believe we cover everything related to the current challenges out there, at the end of this webinar, I will be happy to stay here and answer any of your questions related to any of these topics you hear here today. So again, welcome to our webinar. Let's get started. Technology is redefining how we live. A few short years ago, there were only as few as 15 billion devices around us, and today this number is rapidly multiplying. Today this number is almost 3 times that number as I mentioned earlier. It's over 41 billion these connected electronics will be around us within the next few years. As we go, this number will even get higher, and this increasing number of electronics will drive an even bigger demand for protection for these devices. A decade ago, consumers were willing to pay some premium for a so-called protected device, but in today's world, this protection is expected from the consumers. They expect the protection already in place since they rely on these electronics, and they want them to last longer independent of the environment they are used in. These devices are around us in different environments. These environments could rapidly change, and I can name a few of these environments. For example, the rain, fog, or salt water, or humidity. These could be devastating to any of these electronic devices. The operating environments are harmful by nature, as I mentioned earlier. Not only that the natural environments can harm these devices, but also these devices could be exposed to oils, cleaning fluids, or everyday chemicals. And we want to make sure that since they are widely used, they are part of our lives, they are protected. So we have to find a solution. I'm sure we all realize that no matter what, we need this protection. We need them to survive because we heavily rely on these devices. We need to protect them. So how can we do that? What are the solutions out there today? What solutions can we have now or later in the future? So one thing for sure, that technology is redefining how we live, and we need to adapt to this new environment where electronic devices are part of our lives. So people are and continue to rely on edge computing as the next frontier of computing, and the stakes are high. If the devices we rely on fail, we risk safety, we risk convenience, or we risk a lot. In some cases, our lives can even depend on these devices. For example, the IoT network downtime because of a component failure could cost us several thousands of dollars a minute, and that's a large number if you think about it. And in most of these numbers, or most of these costs could be avoided with the proper planning in place or proper protection in place from day one. On a device, just one given component failure could cause a huge liability damage. For example, in the oil and gas industry, potential downtime can cost tens of thousands of dollars an hour repair cost. That's another large number, and this could be avoided by applying protection to these components. Not just the cost of the component itself, but if you need to send someone there to fix that component or replace that component, that takes time to fly there, takes time to replace the component. So it's a very lengthy process, and then all of these are associated with the costs coming against this procedure to replace these parts. Another example is the cost of automotive manufacturing downtime. You can see there is another large number here, over $31 million a day. If something goes bad, millions of dollars a day failure or cost can be associated with this failure. And then again, repairing or replacing a failed component is timely. And then the product success here is based on the device liability. And as I stated earlier, the stakes are high, the stakes are higher than ever. Something has to be done. Something has to be done here. So what can we do about this? So what does failure mean? So failure, these electronic devices are out there in the environment, and if they are not correctly protected, these devices can corrode. Corrosion can happen with the key components on the board itself. For example, these connection points come close contact with the environment, and as I mentioned earlier, corrosion can happen, and then these elements can be corroded, and then the device can easily fail in a short period of time. These failures could eventually get to a point where the device completely becomes unusable and even beyond the possible repair. And then the corrosion can also migrate to other parts of the board. Once it starts, other parts of the board can be affected as well. And then, especially when these parts are these components are part of the environment, like a sensor, there is not much we can do about it. We rely on these sensors. They have to be reliable, and they have to work under every circumstances, every conditions. So it's time to do something. How can we protect these devices against the environment? It's time to break with the tradition. So what is tradition? In the good old days, there were mechanical seals and gaskets available. These are great, but they fade over time. They might need to be replaced because they crack, or they still don't provide a full protection. You can imagine that nowadays these devices are small, very modern. You don't want to use a very small and modern device with an old gasket or an old mechanical seal. Then, of course, there are traditional conformal coatings, as you can see here in the middle picture. This is better than the old mechanical seals and gaskets, but at the same time, it's still bulky, it's still heavy, it's still a messy process to have this applied onto the board, and they also could fail, or something can be trapped under this conformal coating, so it's still not the best solution. And then, of course, the way how to apply these protections or these coatings are also part of the past, as I call it, so it's not the most modern. So what can we do? So welcome to the future of the protected edge devices. So today we can have access of the next generation of technologies, and these new technologies provide an excellent protection, but without the hassle of all what I just mentioned earlier. Unfortunately, some of these aging technologies are still around there, but here at H0, our goal is to change this and then to have something new, something better. So our webinar today will cover these new technologies, including ways of protecting these electronic components with the next generation thin film protections, with optimizing the design itself for a better device reliability. And then, of course, we will look at the performance of the product for profitability, and then, of course, some numbers, the return on investment, what it really means. So let's see our capabilities. Let's see what we can do to apply this protection for edge computing products. There are some properties we need to be aware of. For example, the physical properties of the device, or of the protection on the device, how much it weighs, how uniformly we can apply it, how transparent it is. You can see a drone here on this picture. You can see that if it's a very bulky, very heavy way of protecting that device, the drone has to work extra hard to fly. It's not the best, not the most optimal way to go. So we have to make sure that the physical properties are in mind when we design a protection. Or of course the protective properties as well. We don't only protect against water resistance, but corrosion resistance, acids, or chemicals. It's important to know what we want to protect against, and then based on that, choose the right technology or right solution. And there are, of course, some additional benefits to consider, like dielectric properties, or what material we apply on the board, if that material has any halogens inside, or thermal stability of the product itself. You can see a webcam here where you see that this webcam is out there in the environment, and then against this environment, different protection level is needed depending on where this product is used or stored, or what we do with that product. So unfortunately, today we don't have time to go into details with all of these properties or all of these aspects of different technologies, how to protect the board itself. But there is this table where different properties of different coating technologies are compared against each other. I can just give you a few examples, but then of course feel free to study this chart or let me know if you have any questions. But you can see that the dielectric strength, for example. Parylene excels here. Parylene is an amazing material to protect against this environment because it can be applied so thin. We can apply the parylene anywhere between half a micron to, let's say, 40 or 50 microns, or anywhere between, depending on the application's needs. And silicons and urethanes are also applied thick enough to work, but they are much thicker and bulkier coatings than thin films. So, as I mentioned earlier, it has some disadvantages. Or abrasion resistance, for example, another example to mention. Abrasion resistance could be reached with some technologies, but there are some thin film technologies out there as well we can use to protect the device against abrasion. Or finally, another example is the water vapor transmission rate. It means that parylene is the best, as you can see on this chart. This is a critical property of the protective coating. When selecting the right technology, we need to make sure that we limit the water exposure, how fast the water can seep through the protective thin film layer. So parylene excels here as well. So there are some technologies out there besides the traditional ways, as I mentioned earlier, how to protect the device. And here at HZO, we have a few ways of doing this. For example, the CVD, the chemical vapor deposition, what you see on the left side, or the PECVD, the plasma enhanced chemical vapor deposition. But there are other technologies like ALD or some other dispense solutions as well available here. But I just mentioned these two, and then you see a simplified sketch of how these work. They are different from the technology point of view, but they provide the necessary protection. For example, the parylene has been around for a while, but we perfected the way how to apply it uniformly and then apply it in a way that it's repeatable and reliable. Both of these technologies happen inside a vacuum chamber, vacuum system, where we apply the raw material through different steps of the process, and then that raw material gets deposited onto the surface uniformly, conformally covering the area and then providing a protection for the device itself. So our processes are better, and they provide a much more robust environmental protection than any of the old traditional coatings I mentioned earlier. And it's very competitive to produce these thin film based solutions. And then these thin film coatings reduce liabilities, costs, and then product failures. And overall, of course, they improve uptime in industrial situations. For example, we mentioned a few properties earlier, physical properties, how heavy it is, how nicely it covers the board, what are the performances, how conformally the protection is applied onto the board, how durable it is. It does not need to be replaced like a gasket or like an O-ring. Once it's there, it's immediately ready to protect. And then, of course, what value they provide, not just from the financial point of view, but I believe I mentioned something like if you don't have to replace that failed component because it does not fail, you save time, you save downtime. And then I mentioned earlier that these are very costly and then potentially can be harmful for not just the environment, not just the board itself, not just the device itself, but potentially the whole company. If you have downtime, your brand suffers. They don't trust that brand anymore if failures happen. So it's important to have the proper protection in place. So let's look at some numbers right now. We discussed the value earlier in this presentation, and then on this coming slide, I'd like to show you the total cost of ownership. So if we can avoid the failures by designing the product the right way with protection in mind from day one, instead of having a protection just as an aftermarket thing on the device, the outcome is excellent. It's a lot more cost-effective way that way. When things fail, not only they are costly, but the reputation of the brand can suffer as well, and then the company could be in danger, as I mentioned earlier during the last slide. So, for example, recalls of the products they could be devastating. We can save on all of these recalls, warranties, and claims by having the correct solution in place at the beginning. So the average cost of recall is over $12 million. And then we can avoid all of these recalls by providing the product on day one, which is durable and reliable. And then if our company's brand won't get damaged by failures, we can boost the customer loyalty, and reputation of our brand will remain or even improve. We can retain our loyal customers for future businesses, of course, that's important. And then the downtime of some potential failures could be prevented for these mission critical parts. We can save hundreds of thousands of dollars by having these durable and critical electronics in our infrastructure system. we can prevent all of these downtimes for these mission critical parts. And then the total cost of ownership is what really matters the most. By having the right protection, huge benefits could be offered here overall. So this is the very reason why for almost a decade, Aidzio has been working with the biggest brands out there to help them achieve these goals. So what does it mean to protect with Aidzio? Here are a few examples on the screen what we can do together. We can help you from the beginning of your design process, starting with the concept development and DFX collaboration. And then this DFX feedback makes the process simpler. Today, we can achieve a robust product where protection is not an aftermarket thing, but rather built into the product itself. And then we can start our cooperation by running a few of the samples, products through our processes, and then provide some data. And then together we can coordinate the pre-production steps and pre-production builds to make sure that the production solution we provide meets your standards and then your expectations. And of course, our engineers are here to provide feedback on how to optimize the process and how to improve the cost and then the product itself. So what is Aidzio? So our mission is to protect the most important thing in the company's life, which is the product itself. Here is a simplified timeline to show that Aidzio has been around for almost a decade. We started as a small company in Utah, but over the course of the time, we grew very rapidly. And then from Utah, we became a global, we have a global footprint. We became a global company providing services to the leading brands from literally all around the world. So we are in Asia, we are with multiple locations, we are in Europe, and certainly here in the United States as well. So we went through some IP development and some acquisitions, but this portfolio is there, it's been there, it has proven itself with the leading brands. We've done it, but more importantly, we've done it in scale, repeatably, reliably, and then with satisfied customers. So this is the end of our quick presentation here, but I'd like to thank you for attending and for listening what we prepared for you. I'm confident that by realizing the importance of the right protection in mind for the product, we'll advance durability and reliability, as I mentioned earlier. So I'd like to ask a favor from you. Please challenge us. Please get in touch with us. Let us know your questions and let us help you engineer the next solution. And let us help you create a reliable product and overall save cost and meet the market requirements. So thank you again for attending here today. So I'm here to answer any of your questions. So with this, I'd like to hand it back to the moderator.